So, hello, Jaime gave it away. SRE was supposed to be a big secret, but now you know, it's site reliability engineering. I am Scott Merrill, Gemini. I live in lovely Columbus, Ohio. I have been with Jack Henry for a little over 2 years now. And this is
Zach McCoy, and I'm a principal engineer here. I've been with Jack Henry for 14 years. I came with the Banno acquisition, and I'm in Cedar Falls, Iowa. So just to give you a little bit of a peek behind the curtains, we've talked about this a little bit in other presentations. We have around 19,000 Kubernetes pods that we run, over 1,000 different services. And that's across about 20-something plus teams. So we have a larger group, a lot of different services. And we're using REST HTTP, as well as event-based microsystems. And we've already said this too, but for user scale, we have 1,030 of you plus, and around 15 to 16 million active users. But the biggest thing is that our scale for team things that we do is much larger. So we use Scala, Go, TypeScript, Rust, Kotlin, Swift, Jenkins for deployments, Argo for deployments, Kubernetes, Istio. This list keeps going on. And as everything kind of gets more and more out there, things get more complicated.
So what is site reliability engineering? Wikipedia defines it this way: a discipline that monitors and improves the availability and performance of deployed software systems and large software services. It's important to underscore in there that this is really a mindset that informs a series of practices. Anybody can do SRE. And in fact, many of you do SRE activities, maybe without even realizing it. SRE, in my opinion, is not really a job. Please don't tell my boss I said that. But it's like DevOps. DevOps was a mentality. It's a philosophy that evolved through hard-won experiences. It's also, in some ways, a lot like QA. QA can't stamp quality at the end of the job. You have to build it into your processes, and that's what SRE is and does. So we're going to use a lot of words today. Some of these we might actually define. But this is a good, if you want to take a picture, if you're not familiar with SRE or practices, principles, this is a lot of the stuff that we will talk about, the domain-specific languages and terms that we will use. You will hear a lot of these. We could talk literally about any one of these topics all day long. So you're all going to get in a very abbreviated 30-minute presentation. SRE originated at Google. The Google website, sre.google, has a lot of information, including a couple of books that they've published that you can read for free, share some of the history of where they've been and how they've got to their decision making. They've got some really great information. They've learned a lot of really important lessons that informs the SRE as a discipline for all of us, but it's important for all of us to remember we are not Google. The lessons that Google learned and the problems that they solved are not the ones that we're always trying to solve, and so their approaches may not be appropriate or relevant. The one thing that Google did get right, unquestionably, is that the North Star is the user experience. We, in engineering and operations, where I come up from, spend a lot of time worrying about CPU load, memory consumption, disk capacity. Your users don't care about any of that stuff. Your users care about, can they access the service to do the thing that they want to do? And Google really drives that home with the site reliability practices that they espouse. The other thing that Google really picked up on and has dispersed throughout the community are the 4 golden signals: errors, latency, saturation, and traffic. These are proxy signals that we will measure to evaluate how happy we think our customers are. We can't interrogate or question every single customer. We can't run a poll or a survey for every user to say, how happy are you? So we set a set of established baselines, and we say, this is what we're shooting for. And if we do this, our indicators are that our customers are usually happy. They keep coming back. They keep giving us money. If our numbers, if our signals deviate from whatever our baseline is in some bad way, our customers don't come back. They don't give us money. That's our indicator that things are unhappy. So the title of this presentation was SRE at Millions and Millions, and the question is, what is different about SRE at 1 million or 2 million or 10 million users? The North Star doesn't change. We still want happy users. The things we measure as proxies for customer happiness, those golden signals, those don't really change either. The processes we use to inspect our systems don't change a whole lot. We might choose different tools or different technologies, but the intents are all the same. What will change are things like our error budgets, our cost of failure, the technology choices we might make. The way you monitor and measure a system that only has 100 active users is very different than the way you would monitor and measure a system that has 15 million active users. So we're going to go talk a little bit about how we measure and what to measure. But before we do, I want to leave you with Goodhart's Law. Goodhart's Law says that when a measurement becomes a target, it stops being a good measurement. So it's important to have measurements independent of what you do with those.
So first off, we need to talk about observability a little bit here. And you'll hear things about 3 pillars. And those are going to be different than the term that we're going to use for observability, but we'll go through the 3 pillars, if you will, first. So those are just telemetry. Those are what we're going to use to measure our users' experiences as well as your systems. So we have logs. Those can be things like structured or unstructured logs. We have metrics, such as CPU saturation, your client total pool, et cetera. And then we have traces, which are really a structured log with time and then causal analysis on top. And really the biggest thing with these types of telemetry is going to be context. Your app's context needs to be on those pieces of data to make it useful for you. For example, what's the amount of money being transferred? How many accounts are coming back? That's data that you can use to parse and look at this piece of data and make decisions. Once we have that then, we can do alerting. So alerting is going to be based off of user experience. That's what we really want to do. We don't want to just alert when we're at 90% CPU. 90% CPU does not mean that our users are having a bad experience. And what we're really trying to get around here then is we're getting around the fact that alert fatigue exists. If you alert whenever the machine decides that 90% CPU is going to happen, you're going to get alerted on so many times that don't actually matter to the user. The one time that it does happen to the user then, you might not actually care. And eventually, we're going to have dashboards for all of that data that we're able to kind of have a visual anomaly detection. You're going to be able to notice when the line goes up, and maybe it shouldn't at this point. But for observability, the term that I like to use for it is the ability to kind of slice and dice your data and ask questions of your system. You want to be able to ask questions of the data that you have for your system, not just your services, but your system, and answer what's happening to these users. Why are they having a bad time? What is the bad time? So this is just a small graph for our systems. But notice that those red metrics and those golden signals are on these. So at the top, we have response timings and P95s. So we can tell the 95th percentile for our users. And we have a threshold or a throughput for active requests. And then we measure our clients, because maybe the client calls that we're making out to another service don't match what the service looks like. Something's happening in between the network. So to measure user happiness, we have certain things like SLIs. And SLIs are just predicates, which really means that they're just Booleans. So for example of this is we have a latency SLI. That might be something like we are faster than 500 milliseconds. Or we have something like an error SLI, which is going to be that maybe we are saying everything's a 200. If it's not a 200, it's a failure. Or we might have correctness SLIs, which is that the data that's coming back is correct. And you can combine these latency, error, et cetera, together to make other SLIs. So maybe that we have to say, all of our requests for this endpoint are 200s and they're less than 50 milliseconds. And what that really gives us then is a predicate to be able to utilize on top of an SLO. And SLOs are service level objectives, which is really going to be a goal percentage that we have. We want to have this much success based on that SLI, which really means that we have this much failure if you do the inverse. And we're really using this for what makes the user happy. How much can it fail and have the user still have a good experience? And we want to use this then as a compass. This should be our North Star. This should be how we deploy. This should decide what we make. And then adding on to that, you have service level agreements, which is really the legalese piece of an SLO. And that goal percentage is hopefully going to be lower than what you are internally putting for your SLO. So these are 3 burn down charts. And this is just measuring all those times that we can fail. We have a bucket of them. Let's say that we have a 99% SLO and 100 events. That means that we can have how many things fail? 1. So what that means is that we have a bucket of times we can fail, and each of these kind of tells a story. So if we start on the top right, we kind of start a normal slope going down, and then we dip, and we eventually get to negative 25%. So we burn 25% more times than we intend to. Our user experience is 25% worse than what we're saying we're going to do. The bottom left, for example, though, tells a bit of a different story. We're slowly burning down and really not doing much. You see a tick at the very end. Maybe we had a bad deploy. Maybe one of our dependencies went down. But the bottom right tells a much different story. It almost looks like the top right. And then we get to that Tuesday or so, and it drops off 60%. 60% of our errors happened in one small amount of time. In that case, it could have been maintenance. It could have been an entire system going down. But what then we need to go do is go figure out what happened and go fix that. So we know failure is going to happen. There's an inevitable piece to it. How do we handle it is the real question. And failure could be anything. It could be the database is down. The service you're talking to is dead. Your system is broken. The client pool is full. What matters then is how we react to it. And that's going to be failure modes. So if your client pool fills up, the failure mode might be that your service restarts. Your client pool is now fixed. It might be that we can't access the database, so we go to cache data instead. We can't access Postgres. So what do we do at that point then? And maybe this is different per system that you have. But really, a failure mode is what you intend to do and still service your customer as best as possible. And then what this really brings us into is as teams, and as teams as part of larger groups, it gets us into systems thinking. We should be thinking about the system as a whole, from the endpoint at the very top all the way to the bottom, rather than my service. Teams falling into the my service trap end up not thinking about the customer just as their service. And so we have to think about these things as components or nodes in a graph, and then connections to them, and how the behavior of one thing in the tree bubbles all the way up to the top. And really, those are emergent behaviors. So we're going to find behaviors that we don't intend just based how things interact. So for example, in our space, using HTTP a lot of the times for a lot of our microservices, we have a couple strategies that we can try. And you can try these 2 on our APIs. We will end up failing on some of those calls. The network is fallible. So we have things like retries, right? On a 500, if it's idempotent, we can retry the call. Eventually, if you retry immediately, you're going to keep just blasting it. And if we're down, we're still down, don't worry. But the retry limit then, let's just say you set that, it's 5. Great, you blasted through it in about 40 milliseconds. We need a different way of doing that. So we have something like exponential backoff. We're going to try, and then we're going to wait, put a little bit of a jitter on it, maybe add 50 milliseconds. We're going to try again. Does it work? No. OK. Add a little bit more jitter, try again. You're at least not taking that service down with you. You're trying to protect it in a way. Really what we're doing is rate limiting. And then eventually we have something like circuit breakers. So we have circuit breakers all throughout our systems. And what they're trying to do is prevent that failure that you're seeing from getting further and further down or keeping all of the systems down below it. So what happens is we have a closed circuit, which means it's going to keep going through. We have perfectly fine calls going right through it. If we're open, then that means that we have failed the actual call itself. Instantly, when we call, it fails immediately. And then we have something like half open, where the call is tried and it's kind of check marked. If it keeps working, we're going to we're going to reclose the circuit so that it keeps working.
So things break, things will fail. We have error budgets that say we're not going to try for 100% perfection because that's physically and mathematically impossible. We will try for 99.9% success, 99.5, whatever the service measure is. But even there, things are going to fall apart, and we need to respond when things break. There's 3 things involved with incident response. The first is rally the troops. There are competing theories in incident response communities and site reliability communities with respect to things to measure during incident response. Some people think you should measure the mean time to repair. And another group of people, the one that I'm in, think that that's a silly thing to measure because the mean time to repair a corrupted database is way different than the mean time to repair a bad deploy. So using one singular metric for wildly different inputs doesn't make a lot of sense. The data doesn't tell you how good you're doing. What a lot of us think instead is you should measure the mean time to respond. How long does it take to get the people engaged to looking at the problem? Are you sitting there spinning your wheels? Boy, is this a problem? Are the customers experiencing this? I don't know. Meanwhile, you're bleeding cash because your customers are upset. Respond quickly. Once you've responded, once you've got the group assembled, you need to make sure that you're not stepping on each other's toes. In the heat of the moment, it's very common for a lot of people to want to do something helpful. Quick, reboot the database. Quick, redeploy. Quick, roll that back. Oh no, change this thing. Change the feature flag. Which one fixed the problem? So what you want is an incident coordinator. It's a traffic cop. It's someone to make sure that you do one thing at a time. Zach, please reboot the database. Scott, please roll back that deploy. Only after each task has been completed do you go on to the next one. It's just a sidebar there. I think it's really important that you use the word coordinator because it is a role of coordination. In the industry, you will see people talking about incident commander, which is a synonym in some ways for this role. I really dislike that because it really implies a command and control decision-making capacity. And in my experience, you don't need any of that to be a good coordinator. You're just making sure that the people who are most engaged and most informed aren't stepping on each other's toes, changing three things at once. You're applying a little bit of calm and sanity and applying the scientific method, change one thing, evaluate the response, change the next thing. You don't need to be the decision maker on that. You just need to make sure that the team does one thing at a time. That's it. Then the other role that's really important is a scribe, a note taker. Someone whose whole job is to sit there and record what happened when. And it might seem like a waste of time, it might seem like a poor use of human capital, but every incident should generate a post-mortem document where you review what happened and you learn. We'll get to that later in a second here. How do you do that if you don't have a durable record of who did what when and what the results of that action were? In the heat of the moment, you're doing a lot of stuff, you're doing a lot of activities to triage, you're trying things, you don't even know. Is this gonna fix it? I don't know. Zach, change the feature flag. Okay, 5 minutes later, the system's repaired. Things are working again. Was it the feature flag that did it? How do we know? How do we know when he did it if we didn't take a note down to say that at 15:52, Scott said, Zach, please change that feature flag. So the scribe is a really important role, and it's one that's easy to overlook, but it provides its value in the long term. Once you've got all that stuff going, then you can start to resolve your problem. That's going to be different based on the technology, the nature of the errors that have presented themselves, how you respond, what your change control process is. Do you need emergency changes? Can you just YOLO and cowboy some stuff out there? There's all sorts of different processes. I'm not here to tell you how to do any of that. You'll need to figure that out for yourselves. We have a process that's hard won, and we've iterated on this over the years. The goal, again, is to get the customer experience back as quickly as possible. And sometimes that means we don't do the optimal fix. We do the quick fix to get the customer experience restored. And then that gives us time to do the optimal fix behind the scenes later. And then review. You want to review what happened. I read a comment on a blog post recently that said, every incident is information. Every outage is telling you something where your systems, processes, or assumptions were wrong. And I think that's really important. The big catchphrase for incident response reviews, postmortems, post-incident review, whatever you want a term you want to use, is a blameless. You want blamelessness in your review process. We never say a human being did an action that caused us to have a problem. We might say Zach did a deploy, but we don't say Zach brought the system down. The system came down because our guardrails did not prevent Zach's crummy deploy from going out, right? our process failed us. Our guardrails were insufficient. And that can be human process to technical process. It covers the whole gamut. But it's really important that we talk about in that language, our systems were incorrect or substandard, insufficient. Our processes were fuzzy, open to too much interpretation that led to this result that was potentially catastrophic. So we really want to work on learning from all of these incidents so that we don't keep regurgitating the same problem again and again, and so that we solve classes of problems by enhancing our processes. We've blitzed through our time, as expected. We've got some links up here if you want to take pictures of these. And again, we're happy to talk about this. We've got 3 more slides. If you're not doing anything with site reliability practices or mentality, the easiest thing to start is with logs. Just log data so that you can say, this happened here. There's a blog post here about canonical log lines. It's kind of a novel topic. It's a really easy thing to implement. I strongly recommend it. The next level beyond logs would be metrics. And those can be anything from gauges to counters to all sorts of stuff. It's a topic unto itself. If you want to go dig in deeper, you can. Prometheus is kind of the open source gold standard for monitoring at metrics. Datadog is a vendor provider that does that if you want to pay somebody a bunch of money for it. And then advanced topic would be traces. As Zach mentioned, it's much more causal in terms of time, duration, and systems integrations. Logs can tell you a thing happened. Metrics can tell you this many things happened pretty easily. Traces can tell you this thing took this long, which is really important when you're dealing with time-sensitive transactions. Again, Datadog is a vendor that provides traces. Honeycomb is another one. If you want some history on SRE, if you want more SRE books from Google, also OpenTelemetry is an emerging standard for the observability standards that we all pursue. And finally, if you like to follow blogs or RSS feeds, I highly recommend SRE Weekly. It's really, really good because they select and solicit input from all sorts of sources, far afield from technology. There's a whole bunch of stuff in there about airline incidents and near misses and what the airline industry has learned about resilience and reliability and how we as software engineers can learn from that. Same with the medical space. They've learned a lot of stuff that we can leverage and implement in terms of non-technical decision-making processes. DevOps Weekly, similar. The Honeycomb blog is fantastic. The Datadog blog is fantastic. And if you're onto Reddit, you can read that as well. All kinds of horror stories, questions, how-to, all kinds of good stuff in there. And we're here all week, so feel free to grab us in the hall. Feel free to talk to us. We would love to talk about this in great depth with anybody. So, thank you.